Hello everyone, this is Mamadou Babai, an Unreal Engine developer at SenseGlove. In this video, we are going to discuss two new features that have been added to our Unreal Engine plugin version 1.6 and see how we can set them up inside the SGBasicDemo project. If you take a look at our landing page on the Epic Store, you would see that the version 1.6 has been released about almost a month ago. And if you take a look at the changelog, if you follow this link here, and you go to our Azure repository, you see that version 1.6 has added support for Unreal Engine 5.3, which is now in preview state, but also two other major features, which one is the ability to throw objects, and the other one was introducing real hands and virtual hands to the API. Basically, now we separate the rendering of the virtual and real hands. We want to go to the SGBasicDemo project and see how we can set up these new features. If you've been following our tutorials and the previous versions of the plugin, you probably already know that we have a project called SGBasicDemo. If you follow this link, and you will land inside our Azure repositories for this project, which basically supports Unreal Engine 5.2 and also Quest 2, Quest Pro, Vive Focus 3, and Vive Pro for Android and for PC on this platform. So you basically, if you need to just check out the project to see the features, you have to first basically select your desired branch and then download this here as a zip file and start exploring the project. But most of the time the master branch is usually on par with the Quest 2 Android and Quest 2 PC branches. So basically there's no difference between the master branch and these two branches, but I highly recommend just check out the label and check out the project for your platform or headset that you have in mind. Anyway, if you take a look at the history, we've already done the setup for you. You could just check out the project and use these features. But I'm going to revert back to this state of the plugin, which was the previous version, and see how we can set up these features that we basically set up in the next few commits here. But the thing is, first let's demonstrate these new features for you, and then we are going to see how we can set up them. Okay, let me run my project. Now my editor is coming up in the first screen. I'm going to move it to the screen that you can see. Okay, now it's open here. So basically, if I hit the preview button here and go inside the VR mode, okay, this is the hand. And this is for the first feature, ability to throw objects. Once you basically have an object, you could just throw it, as you can see. And let's do another one, or for example, grab this one and basically throw it. Oh, I didn't throw it at the right, basically open my fist at the right time, but anyway, as you can see, it's just throwing. So this is the first feature. It should work out of the box, but this feature, the only settings that you have to touch for, I'm going to show it to you. If you basically open the SGPon inside this project, which is the SenseGlove Pon, we already have covered this inside this 90 minutes video, setting up the grabbing and haptic force feedback, SGBasicDemo. In this video, basically, we create this demo project. If you've already haven't seen it, we created from scratch, and in these two tutorials also, because we did develop this on an Oculus Quest 2, but yeah, we added 2 more tutorials for Vive Pro and Vive Focus 3 with wrist trackers that you could use. But anyway, you must be familiar with that those videos. If you haven't seen those, you could stop here, go watch those, and come back here. But anyway, we open the SGPon project here, and here basically inside the SGPon, as you know, here we have like a SenseGlove section, but probably it would be easier to just type in the name of that property that you can basically adjust for throwing objects. It's called max number of hand velocity samples. As you can see, it's inside the SenseGlove section inside SGPon. Basically what this does is going to control the number of samples that we are going to gather for hand velocity when we are releasing the objects, when we are throwing the object. Now it's by default put to 10, the number. This number affects the velocity and the trajectory of the object, that when you are going to release it, it's going to be basically affecting those 2 parameters. For example, if you put this to 1, we are going to basically use the velocity and trajectory from the last frame when the object is released. But if you put it on 10, we are going to calculate the average of the last 10 seconds. For example, this could be useful in situations where you have like a low FPS, low frame rate, and let's say I put it to 1, and when you drop the object, it's just going to basically drop to the ground instead of like when you are throwing it at a certain direction. So you could always, but I think for like a 60 FPS, 60 frames per second, if you're getting that, 10 is a nice number, but you could experiment with it based on your project's requirement and see the difference yourself. This was for the first feature, but for the second feature, let's see the second feature, which is the separation of the real and virtual hand, to see what I mean when I say the real and the virtual hand. So when I go back into the VR preview mode, if you can see my hand, you also see a gizmo. This basically means I have like 2 hands now. The gizmo is 1 hand. We could use a model for that, but I prefer to use a gizmo. It would be easier to see, distinguish the real and the virtual hand. The thing is, for example, if I try to basically put my hands through the platform, let's see what happens. The thing is, my virtual hand, which is the hand that is rendered in the virtual world, has collision with the platform. It's not gonna go through the object, but my real hand does. In the physical world, there is nothing that could block my hand. So as you can see, I just move my hand, which is the real hand, but the virtual hand is basically behaving the way it should in the virtual world, which is blocked by the platform. And now if I just bring up my hand to the air, the virtual hand is gonna follow. Also, it's with the objects as well. For example, let me press this cube. As you can see, the virtual hand stays behind, but the real hand still continues going through the objects. And when I bring back my hand, it's just going to basically they are going to be at the same location rotation. So you can see that here as well. You see it just falls behind, but the real hand continues. So it's even the same with this one, as you can see here. And this is the separation of the virtual and the real hand. But we have to do some extra work for this to work. I'm gonna show it to you before we're going to basically revert the project and see it in action, how we can set it up. Yeah, basically let's see that. I'm going to stop the simulation. The first thing that we have to set up is basically going to the mesh that we are using for the hand, and because I'm using a left hand glove, but also the right hand has a similar thing. If I open the physics asset, you see a collision here. It's a small collision. If I make it big, basically the hand will stop sooner, and there will be a gap between the platform and my hand, so that's why this collision is a bit small. But anyway, we are going to see how we can do that, and also the collision settings for this platform and these objects should be adjusted for this to work. But let me first revert the project. I'm going to close. I'm going to basically the repository, as I said, using this link here in the examples and demo project section. I'm going to revert to this commit here. Let's copy the commit and basically type in git check out that commit. Probably I have something that is not. Yeah, I have to just type in git check out everything. Then again, I'm going to repeat the same command. Now I'm at that commit. I can verify that by git log, and as you can see, I'm at the previous version. So the thing is, I'm going to run the project again. To see if the virtual and the real hand work correctly. It takes a bit of time to, of course, load the engine. So now again, I'm going to the VR preview mode. And I try to replicate the same thing. As you can see, the virtual hand is going inside the platform. So for this to work, because this is like a skeletal mesh, we have to set up the physics for the skeletal mesh and also the other objects. As you can see, it just goes through them. So let's as I said, first, if you are inside the contents folder, you go inside mesh folder, and here for both the left and right hands, you have to go for the physics asset. This one is for the left hand, this one is for the right hand. I'm going to basically press this button, generate all bodies. It's going to create a nice capsule collision for me, and also I'm going to do the same thing for this hand, and I'm going to save it for now. We are going to adjust it, but let's see if that does anything. As you can see, still it doesn't do anything, because yeah, the platform's collision and also the cubes and the spheres should be adjusted as well. So let me go back. Now, we did set up our collision for now, but we are going to fine-tune it later on. We want to just first make it work. Then I'm going back to the content folder, and here I'm going inside the blueprints folder. And what I must do here is basically I go for the simple cube, simple sphere and open them. Here, the root object, the root component inside this cube, simple cube, is basically a cube. I'm going to type collision, and here I'm going to, in the collision type, I'm going to just put in block all, and it's basically going to block everything. I'm going to save. And here I do the same thing for the simple sphere. I'm going to select the root component, and on the root component I'm going to type collision, and I'm going to put it on block all, compile, save. And inside the map itself, also the 4 platforms I have here, I'm going to select them. And here inside the word outliner, beneath that, inside the details panel, I'm going to type collision, and here also I'm going to put the collision to block all. I do the same thing for this one as well. I've already typed the collision. Then I'm going to put the preset to block all. As you can see, it just affects these. Again, same thing, block all. And the other platform, I'm going to choose block all. So I'm going to save the map as well. Let's do this one more time. VR preview. And I'm not able to see my hand in the VR. Now I'm able. There's it seems there's a lag. So I'm trying to just see if my hand blocks. So as you can see, still it doesn't block. What could be wrong? Let's see what could be wrong, because we did set up the collision. Well, we did already set up the hand collision, and also we did set up the sphere, the cube, and the platform's collision. But there's one more thing that we should do, and let's go for the simple cube and make sure the root component is selected. And as you can see, the collision preset is set to block all. But also, in addition to that, if we type here generate, you have to basically generate overlap events and generate heat events. This should be also checked. Compile, save, and do the same thing with the sphere. Select the root component, type generate, and here make sure these are all selected. And let's go back to the map and select the platform, generate, here simulate, generate heat events and generate overlap events. Then we do the same thing with the other platform. You could do so also during the level streaming as well, if you are using the level streaming feature. But anyway, I think this should be good enough for our purpose. Then I'm going to save all. Now I believe it should be working. Let's see. Okay, it's not working. Okay, I think I know what we are missing. The thing is, we have to go back to SGPon, and here open the full blueprint editor. In the previous version of the plugin, we only had the hand left and hand right, which was basically the virtual hand you are seeing being rendered on the screen. But in the new version, we introduced two more skeletal mesh components to the API. One is called real hand left and real hand right, where basically you see the gizmo being rendered. The thing is, even though we are not showing the mesh for the real hand, we use a gizmo, you still have to assign the skeletal mesh asset to it for the collision in order to work. Because we didn't do that, that's why the block collision was not working, because the although we did check the generate overlap and heat events for the simple cube, for the platform, for simple sphere, it's not going to work, because on the other side we are basically checking those events from the real hand left and real hand right. So the only remaining thing I have to do basically is to assign the mesh one more time, this time to the real hand left and also to the real hand right. If it's not working, that's probably the reason, because it's something probably most people tend to forget. I also did. I'm going to choose right for this one. Let's use the same mesh, because I believe, okay, it's not the same mesh. Then I'm going to basically use the same mesh as the one that I used for the left hand, as you can see here. Even if I want to show it, I can assign a different material to it. So I could distinguish between the left hand, which uses cyan color, with this one, which uses a purple color. That would be nice if I want to show it, of course, but at the moment I don't want to. I'm happy with the gizmo. But anyway, let's choose the right map, skeletal mesh. So the thing is, now we assign the same skeletal mesh to the virtual hand and the real hand in order for the collisions to work. As you can see, it's the same thing for the left and real left hand. So I'm going to compile, save, and this should be probably working right now. Let's see. Although the collision of the hand is a bit big, so we have to adjust it, but I believe this should be working. Let's see. Yeah, it is working, but as you can see, there's too much distance between the wall and the hand. It's because the collision is too big. You can see it here, so we have to adjust the collision. I'm going to basically again mention the steps that are required, but first let's go back to mesh, and here select the virtual hand left. You can select the capsule here, and if you press R on your keyboard, it goes to a scale mode. Then you could just scale it, and you should be experimenting with it, like if you are happy with the size and position. Also, if you press W, you could move it, and if you press E, you could rotate it, basically. But I'm going to only modify the left hand, because at the moment I have a left hand glove, but you should also do the same thing for the right. I've already done that for the repository, so once you check it out, it's like it has the correct size. But let's see again. Okay, now yeah, I'm happy with what I see on the screen. Let's see here. Yeah, I'm pretty much happy with it. And I think it's good enough. Now I can mention what we've done one more time. So basically what we did here was the first step we took. in this tutorial for the separation of the real hand and the virtual hand in order to set that up. The first thing we did was basically enabling block all collision on the basically the root component of our grabbable objects. Here was, for example, the simple cube. We chose the root component. We went for the collision. Here we did put it on block all. And the second thing we did here, the grabbable and also the platform, we did the same thing inside the map. If we here we type collision, we did put it on block all. And in addition to that, also we did enable generate hit, and as you can see here, overlap events. That's the second thing we did. Also we did it for our grabbable objects, like on the root component of the grabbable objects. Here if I type the collision, as you can see, basically we did after putting it into block all, we did enable the generate hit and also overlap events. The third thing that we did, we opened the basically physics asset for our left and right hands, and what we did, we generated the bodies, generate bodies inside the physics editor. They call it FAT inside Unreal, physics asset editor. And the thing is, after we did that, we created this collision and then adjusted it. And the last thing we did was going to the SGPawn, and inside the SGPawn we did for the real left right hands, what we did was basically assigning the same skeletal mesh as the left right hands, and that's it. That's all we needed for this feature to work. So basically, if you take a look at the options here, it's just like the same thing as the hand left and right, the real hand left and right. And also if you take a look at the SenseGlove section, here you see the only difference is they enable the draw debug virtual hand. We don't have that on the you could also enable that the gizmos for the left and right. If you don't want to see the real hand, you could just turn this off and it's going to basically disappear. We don't have it on the virtual hand. We only enable this for the real hand, and because these are they are using draw debug lines, in your release builds you are not going to see them anyway, but you can always turn it off from here. I hope you've enjoyed this tutorial, and that's it for today.